Welcome back to the deep dive. We're exploring the universe together, and today we're diving into something really cool for our Science Corner series. We're talking about interstellar objects.
Cosmic wanderers.
Exactly. Objects just drifting through space, not tied to any star system. And the amazing thing is we've actually seen them right here, passing through our own solar system. So today, we're going deep on the 3 confirmed ones we know about. We want to unpack their stories, what makes each one special, and importantly, what can these visitors tell us about the universe way beyond our neighborhood? We've pulled together info from quite a few recent scientific papers and observations for this.
And that's really the key, isn't it? Why they're so important. They're essentially messengers from other stars. They carry clues about how other systems formed, maybe how they evolved, and they definitely challenge our existing models.
Right. So let's just clarify, what is an interstellar object exactly? We're talking about something astronomical, but it's not gravitationally bound to a star, like our sun. It's a rogue body, basically.
Just traveling through interstellar space.
And when they swing by a star, like ours, sometimes they get called interstellar interlopers.
Yeah, and because these are such, well, unprecedented discoveries, the International Astronomical Union, the IAU, they actually set up a specific way to name them. That's where you get the designations like 1I, 2I, 3I, that literally stands for interstellar.
Ah, okay. So it signifies it's something truly different.
Precisely. It marks them as unique events, scientifically speaking.
Now, before we actually found any, what did scientists expect to see, if anything?
Well, the general thinking, the sort of prevailing idea, was that if we found one, it'd probably be a comet.
A comet, why is that?
It comes down to how planetary systems form and evolve. It's generally thought to be easier to gravitationally eject icy bodies, comets, from a star system compared to denser, rocky asteroids.
So the expectation was ice, maybe with a tail?
Exactly. Something that look familiar just from far away. And when you think about the sheer scale, current estimates are pretty mind-boggling. They suggest several of these objects might pass inside Earth's orbit every single year.
Several a year? Wow.
And maybe as many as 10,000 passing inside Neptune's orbit on any given day.
Okay, so that leads to the obvious question. If they're potentially that common, why did it take until, relatively recently to actually spot one?
That really comes down to technology. Our ability to scan the sky, detect faint objects moving quickly, it's improved dramatically. Which brings us right to the first big one.
Oumuamua, discovered back in October 2017 by the Pan-STARRS telescope. That really kicked things off, didn't it?
It absolutely did. And what was so fascinating right from the start was how it just defied those expectations we were talking about.
How so?
Well, instead of looking like an icy comet, it appeared much more like a rocky asteroid, sort of dense and inert. Crucially, it didn't have that fuzzy halo, the coma, or a tail. The things you see when solar heating vaporizes ice.
So, no tail, no gas, just this rocky thing. That must have been a surprise.
A huge surprise. It immediately made astronomers question those initial assumptions.
And wasn't it tricky to even study? I remember reading it was already heading away from us when found.
That's right. It was only detectable for about 80 days, a very short window.
80 days?
Yeah.
To study something from another star system.
Exactly. Very limited data gathering time, as it was already on its exit trajectory. And that trajectory itself was telling. Its eccentricity, which measures how stretched out the orbit is, was 1.199.
And anything over 1 means?
Means it's not bound to our sun, it's not orbiting, it's on a hyperbolic path just passing through. That high eccentricity was the smoking gun for its interstellar origin.
Okay, so Oumuamua was the oddball, the unexpected one. But then came the second one.
Yes, 2I Borisov.
Discovered in August 2019, and this time by an amateur astronomer, Gennady Borisov in Crimea, which is pretty amazing.
It really is. A fantastic example of citizen science contributing to major discoveries. And the fascinating thing about Borisov was, well, it was almost the opposite of Oumuamua. It fit the predictions almost perfectly.
Ah, so it looked like a comet.
Yes, very clearly. It had a distinct coma, that gaseous halo, and a visible tail, just like the comets from our own solar system.
So that must have been kind of reassuring in a way.
It was, yes. It suggested our models about ejected icy bodies were broadly correct. But of course, it also made Oumuamua seem even weirder by comparison.
And Borisov put on quite a show, right? I remember reading about its tail size.
Oh, it was impressive. The tail grew to be about 14 times the size of Earth.
14 Earths. But the actual core, the nucleus, was small.
Estimated at less than half a kilometer across, yeah. So tiny nucleus, enormous tail. And we learned some really interesting things about its composition, too.
Like what?
It seemed relatively low in water and diatomic carbon C2 compared to typical solar system comets, but it was enriched in other things, like carbon monoxide and amines. It even showed a tiny bit of neutral nickel emission, which was unusual.
So different ingredients than our local comets.
Potentially, yes. It hinted at the diversity you might find in material from other star systems. Maybe different formation conditions, different chemistry.
And because it was spotted on its way in, we got a longer look at it.
Much longer, thankfully. We could observe it through late 2019 and into 2020. It came in from the direction of Cassiopeia, heading out towards Telescopium.
Tracing its path, originating from the galactic plane.
Seems likely, yes.
It got nicknamed the Christmas comet, too, didn't it?
It did, because its closest approach was around the holidays.
Yeah.
There was also a point where we thought the nucleus might have fragmented, broken up.
Right.
But later analysis suggested it was probably a large outburst of gas and dust, not a complete breakup. Still quite dramatic, though.
And its trajectory. Even more unbound than Oumuamua.
Even more so. Its eccentricity was measured at 3.36. Extremely hyperbolic. No doubt about its interstellar origins.
Okay, so we have this strange Oumuamua, the accepted Borisov, and that brings us to the most recent discovery.
3A.
Found by the ATLA survey, Asteroid Terrestrial Impact Last Alert System on July 1st, 2025.
And interestingly, ATLAs also seems to be behaving like a comet. It's showing a coma and a short tail.
So another one fitting the general expectations, like Borisov.
In terms of appearance, yes. But what's really catching attention is its potential size. The nucleus is estimated at maybe 4 to 5 kilometers in diameter.
4 to 5 kilometers. That's quite a bit bigger than Borisov.
Potentially an order of magnitude larger, yes. About 10 times bigger.
And it breaks the record for eccentricity, too.
It does. A whopping 6.15. The highest yet for any confirmed interstellar object. Really screaming through space.
Wow. Okay, and its path. It comes closest to the sun in late October 2025.
October 29th is perihelion. But unfortunately for Earth-based observers, we'll be on the other side of the sun then.
Ah, shame.
But it makes a close pass by Mars earlier, on October 3rd. So there's a chance the orbiters there might get a look.
Oh, interesting. Could we get data from Mars?
It's a possibility scientists are certainly considering, and it should become visible again from Earth by early December 2025.
Now, the really mind-bending part about ATLS, this hypothesis about its origin. Tell us about that.
Right, this is where it gets truly exciting. New calculations, looking at its trajectory and likely composition, suggest it might have originated from the Milky Way's thick disk.
The thick disk, that's an older part of the galaxy, right?
Much older, yeah. Populated by older stars that formed when the universe had fewer heavy elements compared to, say, our sun's neighborhood in the thin disk.
And what does that imply for the object itself?
Well, it implies it could be incredibly old. The analysis suggests maybe a 2/3 probability that it's over 7 billion years old.
7 billion years. Older than our own solar system.
Potentially, yes. Which is just staggering to think about. It would be like a relic from the galaxy's earlier history, long before our sun even formed.
How can they even estimate an age like that?
It involves complex probability simulations. They model star trajectories using vast amounts of data, particularly from the Gaia satellite, which maps star positions and movements with incredible precision. By tracing ATLA's likely path backward through time and space, they can estimate the probability it came from different galactic populations, like the thick disk.
And that thick disk origin also suggests something about its makeup. You mentioned fewer heavy elements.
Exactly. The idea is, if it formed around an older, thick disk star poor in heavy elements, the building materials available would be dominated by lighter elements. That could mean it's potentially very rich in water ice, made primarily from hydrogen and oxygen, which were abundant early on.
Okay, but this is still a hypothesis, right? How do we confirm something like that? An ancient, water-rich comet from before the sun existed.
That's the critical next step. We need more observations, especially as it gets closer to the sun and starts outgassing more. Studying the specific elements and molecules in its coma, particularly the abundance of water, will be key. It's like that analogy one astronomer used, like playing Wheel of Fortune.
Wheel of Fortune.
Yeah. Right now, maybe we have 4 letters out of a 20-letter phrase. We can guess, maybe even make an educated guess, but we could still be completely wrong. We need more letters, more data to be sure.
That makes sense. So looking at the bigger picture then, we've gone from 0 confirmed interstellar objects to 3 in just a few years. What does that tell us?
It tells us they're definitely out there, and our ability to detect them is rapidly improving. It suggests this is just the beginning.
And future telescopes like the Vera C. Rubin Observatory, they're expected to find many more.
Oh, absolutely. Rubin is designed for exactly this kind of survey work, scanning huge swaths of the sky repeatedly. Expectations are it could find potentially, several interstellar objects per year, maybe even more.
Wow, so this could become almost routine.
Relatively speaking, yes. Turning these from rare curiosities into a population we can study statistically. And these discoveries open up other fascinating questions, too. Like, could some objects already in our solar system actually be captured interlopers?
You mean objects we thought were ours might actually be from somewhere else?
It's a possibility that's been seriously proposed for a few objects with weird orbits or compositions, like asteroid Oumuamua, or maybe comets like Machels 1 or Hyakutake.
Ah, never thought of that.
And the flip side is true, too. Objects from our solar system can get ejected. Comet C 1980 E1 is a known example that got slung out by Jupiter's gravity. It's a two-way street.
It really paints a picture of a dynamic galaxy with stuff constantly moving between star systems. And inevitably, it brings up that panspermia idea, doesn't it? The sources mention it.
They do. The idea that the basic building blocks of life, or maybe even dormant microbes, could potentially travel between star systems clinging to objects like these.
It's speculative, of course.
Highly speculative. But it highlights the potential for material connection across vast cosmic distances. It's a fascinating, if unproven, concept these objects bring to mind.
Given how fast they're moving, is there any realistic hope of sending a mission to actually visit one?
It's incredibly challenging. Their high speeds make rendezvous or interception extremely difficult with current propulsion technology.
Yeah, I imagine trying to catch something zipping through that fast.
But scientists are already thinking about it. There was Project Lyra, a conceptual study for a mission to chase Oumuamua, though it would take decades to reach it now. And there's the Issa-Jaksa Comet Interceptor mission, designed to wait for a suitable long-period comet, or potentially an interstellar object, and launch quickly to meet it.
So the ambition is there, even if the technology is still catching up.
Definitely. The scientific payoff of studying one up close, maybe even getting a sample, would be immense.
So recapping our journey today, we had Oumuamua, the mysterious first arrival, then Borisov, the classic comet from afar, and now ATLS, potentially an ancient messenger from the early galaxy.
Each one teaching us something new, refining our understanding, and frankly, deepening the mystery.
It really feels like we're just scratching the surface.
Absolutely. These objects are like time capsules, carrying information about the conditions, the chemistry, the history of entirely different parts of the galaxy. They connect us to the broader story of stellar and planetary evolution in a very direct way.
And as our technology gets even better, as we hopefully find more of these visitors and get more letters for our cosmic wheel of fortune, what else might we learn? What secrets about the universe's origins, about how common or different planetary systems are locked away in these silent travelers? It really makes you wonder what else is waiting just beyond our doorstep.